want to, so in behavior is something that's going to stick with us through, actually all of this will stick with us through the rest of the.
Extreme?
It's Extrema. Extrema is the plural of extreme points. So I wrote it that way, but we're actually going to talk about in behavior first. Okay. All right, so what in behavior does is exactly what it sounds like it does. It describes what the graph does on the ends of the graph, like where it goes on. You know how we got these arrows that go on forever? All right, so that's what it does. It describes how many ends would a graph have?
4.
2, that's right. Both ends of the graph. So I need to teach you a little math lingo here to understand in behavior.
Why is it only 2? Is it 4 arrows?
No, any graph you do, let's say this was my graph. We're talking about this end and this end. Okay, what the ends of it do. Oh, no. All right.
That means the X brings the Y.
Yeah. It's okay. Calm down. Don't stress it so much. You look completely and totally dejected right now. Let's quit stressing the...
Look outside the room.
All right, so again, tell me what this symbol means.
Infinity.
Infinity. Negative infinity.
Yes.
I'm going to show you a little mathematical sentence. Shh, 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 shh. And let's see if you can figure out what this means. If I tell you, bless you, that's exactly right. As x goes to infinity, sometimes we say this is approaches, okay? Because it can't actually be infinity, right? That's kind of a conceptual number, conceptual value. So as x goes to infinity, or as x approaches infinity. Now let's think about this on a graph. I told you there are 2 ends to a graph, right?
4, yeah.
2, quit saying 4. Okay, I'm on this coordinate plane and I have this cubic graph. I have 2 ends, do you agree? Okay. I have always a right end and a left end, do you agree? Okay. Do you also agree that each end is either going to go normally up or down?
Wait, not all the time.
Not all the time normally.
No, there can be a straight line.
There could be, right, or we're going to talk about,
right.
okay, but it's going to be left and right. We're going to talk about left and right. Those are the 2 where,
Straight
okay.
up and down.
But,
Or if there's like a little
Lord.
C, there's no left or right.
Okay, we're going to talk about the left and the right ends. Okay, so I want you to think about this for just a second. Using this terminology, this as x goes to infinity, what might I be talking about?
The line.
Which is x and which is y? X goes to infinity. Infinity's really big, right? Which direction does x get really big? To the right. That's what I wanted you to get there. To the right. So this is saying on the right end of the graph. Does that make sense?
Isn't that to the left too?
So as x goes to infinity, which means look at the right side of the graph. If as I truck this way, x is getting bigger and bigger, right?
Yes.
So the bigger x gets,
Oh, it'd be negative. Left.
tell me what is the graph going to?
Oh, infinity.
Positive infinity, right?
Right.
Because it's going up. It's getting bigger, 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 right? As I move right,
It's
the graph is going up.
But as you move left, it's getting small. Well, more negative. Yeah. It's going down.
F of x is the same thing as y.
When you're saying the graph, are you
To
saying...
the picture. Look at the picture.
But it's also going down.
But right now I'm only looking
You're
at the
only
right
talking
side.
about X.
Right.
Okay.
Because I'm going to describe both ends because there's 2 ends. So on the right side, the graph is going up.
Yep.
How could you describe the other side using this new
It's
notation?
going,
As
as x goes
to negative
to
infinity.
negative. F of x goes to negative infinity.
That's exactly right.
Am I doing
That
It'd
says
be left down.
the left side of the graph goes down.
Yes.
The right side of the graph goes up.
Exactly.
Is that easy?
Why you have to write that?
Is that all we doing tonight?
At the end.
Wait. Okay.
No, we still have 2 4.
Listen, this is, some people get this the first time I put it up here, and some others of us it takes a little while, so y'all bear with me, okay? We're gonna do several of these. There will always be 2 parts, because there's always gonna be 2 ends of the graph. There's 2 arrows, right? All right, so I want you to look at this one. Here's my graph. Describe the end behavior of the graph.
Okay.
As X goes.
Wait, let everybody look and then we'll do it. I'll let you answer. Just wait just a second.
For X, it's the same thing. For Y, it's
Wait.
It's a little different for Y.
It's a little different. Shh. Here we go. 2 sides, so I need 2 sentences, right?
Yes.
All right.
As X goes to positive. And
Uh-huh.
F of X goes to positive.
Exactly. Which means the right side goes up. As X goes to,
Negative. Aaliyah said negative X.
okay, they both go up. Listen,
Oh, shoot.
do you see the pattern here though? This is the same every time. Every time that's the same. The only thing you're changing is whether it's positive or negative. Is it going up or is it going down? I'm saying every time you do in behavior, these 2, this is the same. Every time. For every problem, this is the same. Every problem, the only thing that's changing is the sign.
So if everything's like on the left side is always negative, so that's like the first one.
Alright.
Yes.
So it's always negative on the
Yes.
left. But then like if it's going up or down, it's positive.
Right.
It's negative that logic.
Because X goes to negative infinity this way and positive infinity this way. So positive infinity for X is right and negative is left.
Yeah.
Hold up.
What's wrong, Robert? What's wrong?
So X, as X goes to
For one time,
positive.
They've been figured out.
All right, one more, guys. Uno
Do you want to give us
mas.
a hardy? Hardy?
You can't really make these hard.
Give us a
Yeah, I don't really know how you
complication.
reform.
Ew.
Can you draw the graph there for us?
No.
Same thing.
Yes, please.
Yes, please. Thank you. Next.
You're welcome. What I was saying about things being the same is I can go ahead without even looking at it and do,
F of X goes to negative.
Actually, no, F of X. Yeah.
It goes to negative.
You're
Positive, if X is positive,
it's going down. It's not going down as fast, but it's okay because it's still going down. It's steadily going down. So I'm still approaching negative infinity. I'm still going
One
down.
day it'll be there.
So they're both negative?
No.
The left side's going up.
I got it right.
See how this side is creeping up as it goes? This side is creeping down as it goes.
So the bottom is negative.
Yes. That Extrema.
These plans are too hard.
Wait, was that not what we supposed to do?
That was in.
Extrema. All right, so extrema are just what they sound like. They are extreme points, okay? And by extreme points, I mean really high points, really low points, all right? We also use zeros to talk about extrema. Landon, if you'll put that away, please. So let's say I have a graph that looks like this,
With.
okay? That's a cubic.
No, it's extreme.
Oh, extrema are highs or lows. We talk about high points. High points we call maximums. Low points we call minimums. And zeros,
It's called 0.
where it crosses the x-axis. But yes, we call those zeros. Okay? Nope. Nope.
They better figure out why. Like, all the lower school's probably doing it.
All right, here we go. High points, low points, and zeros. Those are the extrema that we're going to be talking about. So as you look at this, I see all three of those within this graph. Okay? What do you think a maximum might be here?
Infinity.
As
Definitely
X?
infinity.
No, you
How would
can't
it
do
not be? It goes all the
infinities
way.
because it keeps going. So you got to define them. But I wanna kind of piggyback on that for just a second in a minute. Whenever we find this, this would be a maximum. Okay, it's a high point on the graph. Do we all agree?
Yeah.
Now Dylan says infinity, and he's not wrong that it goes up forever. The reason, or actually, let me say it this way. This is called a relative maximum because it is a high point on the graph, but Dylan's right, it goes up forever and ever and ever. So it's not the highest point on the graph, okay? If it was the highest point on the graph, the highest point. Yeah, you gotta read that right. The highest point. We would call that an absolute max. Okay? And you don't have to have an absolute max. All right? It's never infinity. We can't use that. It's got to be a specific point. But here, this would just be a relative maximum because there are higher points, but at the same time, it's still a high point. Now, notice some things about this maximum. There's some other words we use that we'll use more as we go. Several things happen at this maximum. Obviously, it's a
goes
high
back
point,
down.
right?
Yeah.
You're exactly right.
Starts to go off.
That's the point where it changes direction.
He pulled a
Okay?
parachute.
It starts here, if you look, we're going up, 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 up. At the point we hit that maximum, that's where we start going down. So sometimes we might call it a change of direction point or an inflection point where it changes. A turning point is another word. Did you know that? Or did you just guess?
I was just saying.
That's actually, that is a term we use for
Inflection.
extrema like that. Yes.
Inflection.
No. Okay.
It literally
Relative
fits it so
maximum.
well.
That's actually a good.
Right when we get to the
All right.
top, we'll be like, this is the maximum.
This is the turning
Nice try.
point, guys.
Okay, guys.
What is the slope of this roller?
What is this called?
That's called a minimum. That's a minimum.
What a relative minimum. Why is it relative and not
It
absolute?
goes all the way
It
down.
gets.
That's as low as we can see.
It's a low point, but yet this graph goes off forever that way, so it's not the lowest
Okay,
point.
but if you ask me why that's only a relative,
All right. No. You're not going to have to explain. You're just going to have to say, is it relative or absolute? All right. Do you see any zeros on this graph?
Yes,
I mean, like,
sir.
kind
Yes. How many?
1, 2, 3.
I thought no one gives us 0, 0.
No, Coffin.
6,
Still no, Coffin.
7.
All right, so zeros are places where the graph crosses the x-axis, all right?
We have to graph these or just,
All right, yes, we're going to be graphing.
this is a lot of work. For what?
The Extrema.
Oh, just wait, because we're going to graph.
We only have to
Just
sketch
wait.
it though, right? We only have to sketch it.
All right, let me show you one more. I want you to label the extrema on this one, and we're going to describe the end behavior.
Yeah, but we got like 40.
I was going to say, it's just 10:30.
Dang, it's that so long.
All right, take a second. Tell me.
I got you. We got first.
As x approaches positive infinity, what does f of x do?
Oh, wait, do that too?
Oh, we were supposed to
I didn't know we had to do that.
I didn't know.
Wait, do we have to write plus?
No, you don't. If you don't write anything, it's an implied positive. Both ends go up, so both ends are positive. That's exactly right.
So it doesn't matter. Well,
It doesn't matter if it goes down first.
yeah, because that would be your extreme, right? You just count that.
Right, yeah. How many zeros did you find?
4.
1, 2, 3, and 4. 0, 0, 0, 0.
Oh, I did, yeah.
Press X.
What is this?
That, where what?
Where are you?
Where
That's
are we?
money.
It turned off.
No, it didn't.
That's the
What about this yellow place circle?
That's the lowest, absolute minimum.
Okay, yes.
Relative max.
Oh, it's.
All right, let's see how well you really understand. Listen to the scenario.
So you're not gonna graph these?
Listen to the scenario, and I'm going to have you sketch a graph without an equation.
Dang, dude.
Oh.
Well, we have to have like 20.
All right, listen.
All right, I'm listening.
I want you to graph this non-linear function. Okay? Here are the criteria. The y-intercept is -5.
Yeah.
Yeah, the function is continuous.
Okay, so it can't be a straight line though, because it's non-linear.
It's non-linear, so it's not a straight line.
Oh,
The function is positive. Now, what do I mean whenever I say the function itself is positive? Let me say this. I can't remember if this was my first block or y'all that I told. Above the x-axis is positive. Below the x-axis is negative.
Okay, so it has to be a
Okay.
parabola or polar.
We say the function is positive. So this one, if this was -1, come on, and this was 1, we would say the function is negative between -1 and 1. Okay, because it's below the x-axis between those two numbers. All right, so this particular function is positive for x is less than -3 and x is greater than 4. Okay, if you wanted an interval notation, so from negative infinity to -3, the function is positive, and from 4 to infinity, the function is positive. Okay? The function has a minimum. I will not tell you if it is a relative or an absolute, but it has a minimum at 2, -6.
You know what number this is? I can look it up
Right.
And it is increasing. Now, increasing means as you look left to right, it's going up, right? It is increasing when x is greater than 2, which means from 2 to infinity.
later.
Okay?
How's the y-intercept -5 if it's positive?
The end behavior as x approaches positive infinity. These are fun, y'all. Think about them like a puzzle.
But how can it be positive if the y-intercept is -5?
Can you re-explain the positive?
It's gonna go like up and
Yep.
down.
All right, give me just a second. Both ends are positive here. Okay?
Okay.
All right, let me make sure I gave you everything you need. The y-intercept is -5. The function is continuous. The function is positive for values less than -3 and bigger than 4. The function has a minimum at 2, -6. And it's increasing for when it's bigger than 2. And the end behaviors are both ends go up.
Yeah.
Okay?
Yeah.
All right, so let's think through this. Okay, somebody said to re-explain the increasing. Increasing means as you look left to right on the graph, let me find a piece that's, you should have learned this in Algebra 1, so it's kind of assumed, but if you didn't, that's okay. It's a really easy, as you look left to right, see how this is going down until I hit this point? That interval is decreasing. Then as I hit this minimum, it goes up, 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 up until here, so that's increasing. So it means as you move left to right, it's going up. That's what increasing means, okay?
Yeah, I don't understand positive negative.
Okay, so if the function is positive, that means it's above the x-axis. So if I told you that it was positive when x was bigger than 3, then that means wherever x is 3, if I was on a graph, 1, 2, 3, from this point over, all of my graph would be above the x-axis. A function is just a graph. Function just means that it passes the vertical line test. So whenever I say sketch the function, all right, watch, let's do this one together. They're not as hard as what you're making them, I
No, they're
promise.
really not. Can I do it on myself, actually?
You just have to understand the vocabulary that goes along with it, okay? All right, so here's what I know. Looking at this one, I really feel like I should do this one on the board and leave this up here or something. It's really not bad. It's really not bad. If you think about, so smaller than -3. All right, let's go ahead and do y-intercept at -5.
I literally had it going.
1, 2, 3, 4. It's going to cross the y-axis at -5 regardless, right? That takes care of that. At -3 and at 4, that's where it's changing signs. If it's changing signs and going from positive to negative or negative to positive, then what's happening at those points?
Going on. Wait, what were you asking on the graph?
Can you re-say that?
All right, think about this. Now think about it on a graph. If your function or your graph goes from being negative to being positive, or from being positive to being negative, what has to happen to make it change?
It goes through the x-axis.
It has to go through the x-axis. So really what they're telling me is these are what? Zeros. Is exactly what
Well,
that's
that's why I
telling
put
you.
the point there. Yeah,
Right?
I put my point there.
Okay, so -3 and 4. So 1, 2, 3. 1, 2, 3, and 4.
Yeah, that's what I have written down.
All right, smaller than 3. Smaller, so this way. So I'm going to be up here somewhere, then I'm going to be down, and then I'm going to be up.
Yeah.
Right? All right. I have a minimum at 2,
But it's
-6.
lower than the y.
2, that's fine. 2, -6. That's a minimum,
Yeah.
okay? And that was given to me. Is everybody trucking with me so far? All right. Now, the only other thing I know is that when it gets bigger than 2, it's increasing. Not that that's the only increasing interval, but bigger than 2, it's increasing.
Well, that's easy.
Well, that's easy.
That's easier to know.
Okay? That's increasing in that interval, right? All right, so now I'm going to look. I only have to satisfy my end behavior, and the end behavior says that both ends go up.
But
Right?
I got it.
So this is going to go up, and this is going to go up. Now, as far as all the rest of it, as long as I go through this point, I'm good.
Yeah, what if we just, like, does it have to have that little curve?
No, because it didn't say it was. It could be. You could have sharp points.
Yeah, I do have. I like it. Well,
That's
then,
fine.
no, but it's gotta be continuous.
That is continuous.
It is.
Just because it's not curved, I don't have to pick my pencil up. It's good. Does that make sense?
Okay, I got it. Okay, the continuous.
We'll do one more.
Okay, so I was close.
Yeah, I don't understand how it's discrete and continuous.
Discrete is points, continuous means you can draw it
It
with
can,
them.
will it be drawn if it's discrete?
Go, one more. This function is continuous and symmetric.
That's easy.
About -1.
Why about?
That's symmetric about the line. That's the line of symmetry.
Oh,
Okay? So if I'm on a graph, I'm thinking at -1, this is an axis of symmetry.
okay.
The function has a maximum at -1, 4. And the end behavior,
What's the minimum?
no minimum. I'm not going to define a minimum. Both ends are negative.
Oh yeah, because it's gonna be going down.
Anybody guess what this is
It's
going to
just a
look like?
It's just a parabola.
That's exactly right. This is just going to be a parabola.
Upside down.
An upside down parabola. You're exactly right, because it's a max at -1. Now, notice I didn't tell you any zeros. I didn't tell you positive, negative. I didn't tell you any. That's all I told you, but that's okay, because I can satisfy this way.
Yeah.
Okay? I mean, in reality, even if you came over and did this, oops, that, you're still set. That's what I'm saying. There's not really these a lot as long as you meet the criteria that are given and you can sketch the graph. Okay, this is just really getting you acquainted with the vocabulary forwards and backwards.
Kind of like
Okay.
it.